Cognigy uses natural language understanding, or NLU, to analyze user inputs and map them to an intent that the bot can fulfill on. For example, if I want to upgrade my seat, I might say I want an aisle seat. Can I get a window seat? Or are there upgrades available to first class? We can't predict all of the ways a user might express their desire for an upgrade. We need some way to teach Cognigy enough variations on what a user could say so that Cognigy can understand all of the unpredictable ways users actually express themselves. We do this by creating a machine learning model that's intelligent enough to interpret what our users say and map it to an intent the bot can handle. Cognigy makes all of this straightforward to set up, and you don't need to be a data scientist to achieve a high level of accuracy in your intent detection. One way to enrich your NLU is by teaching it special key phrases that are unique to your brand or to your knowledge domain. For example, for an airline, important key phrases could be arrival, departure, and upgrade. For a product company, important key phrases could be your product names. For a technical support bot, important phrases could be computer parts like screen, power supply, or drive. Cognigy organizes these key phrases into lexicons that let you define and categorize these domain-specific terms. Why do we need NLU, and what are its alternatives? Could we make bots that address customer needs and create a good user experience without any machine learning models at all? Well, in some cases, giving users predefined choices could be a more efficient approach to serving them, rather than making them provide natural language inputs. For example, if I'm checking on my flight status and the bot needs to confirm that the flight's UA 7371, it might be easier to just present a yes button and a no button. Particularly on mobile devices, tapping is faster than typing. Or for booking movie tickets, it might be easier for users to click a movie title, a showtime, and the number of tickets, rather than typing out, "I want 3 tickets to see a specific movie at a specific time." But imagine the same interaction through a voice channel. On the phone, I don't always have visual choices in front of me, so it may be much more efficient to speak my request rather than going through a questionnaire-style interaction. So when and how you use NLU will be determined by the nature of the task the user is trying to accomplish and the context in which they'll be interacting with the bot. NLU models are often optimized for specific languages. When you create a new agent in Cognigy, one of the first things you do is choose an NLU language. Cognigy AI's onboard NLU is pre-trained with curated data from over 100 languages to support intent recognition and key phrase detection. Any other natural or artificial language is supported based on language-agnostic NLU algorithms. For 20 of the most common languages, Cognigy AI provides pre-built entities that allow automatic processing of inputs like dates, currencies, and others specific to a language that's defined in the flow. The generic language option extends the Cognigy NLU's compatibility with over 100 languages by employing an advanced multilingual machine learning model. The generic language allows you to do intent mapping in any language, which, along with key phrase detection and our powerful rule intent engine, enables you to build flows in any language. Let's make this more practical by looking at how to build lexicons and intents in Cognigy AI. We'll start with lexicons. When you create a new agent in Cognigy, you can choose one of our pre-built lexicons in the pre-made skills page of the wizard. You can choose things like cities, airport codes, holidays, and more. You'll find those lexicons and have the ability to create your own if you go to the left bar on your agent dashboard and select Build, then Lexicons. If I look at my airports lexicon, I'll see a list of every airport code, and I can sort these and search them. If I search for SFO, for example, I'm taken directly to that entry. You'll notice that each airport code is associated with a slot. A slot is a technical term used when discussing natural language processing that refers to types of attributes. So cities could be a slot, as are airport codes or flight status. Think of slots as just a category name for a group of words. You'll see in Cognigy that we sometimes name things in ways that exclude spaces. So the airport code slot name has an underscore rather than a space. You may also see times where two words are combined into one, with the second word capitalized. Most of the time, this is not necessary, but there are circumstances where having a single word makes it easier to work with Cognigy script, for example, so you'll often see that as a naming convention. I'll create a new lexicon by going to Build, Lexicons, and clicking New Lexicon. Sticking with our aviation theme, I'll call it Airlines. To start populating my lexicon, I can type in a new key phrase and press Enter. For my slot name, I'll call it Airline. I can also add synonyms, which could be all the different names a user may call an airline, like United or UA. If Cognigy sees that the synonym is used in a user input, it will treat that as a match for the key phrase. A user who says, "I have a flight on United," will get a match for the full key phrase United Airlines. Another example could be adding city names as synonyms for airport codes. So the airport code SFO, I might add San Francisco as a synonym. That way, if the user says, "I have a flight departing San Francisco," the bot will see that as a reference to the airport code SFO. After I type each name, I press Enter to submit the new word. To delete a word, I can click the X next to it. I could build my lexicon one word at a time in this UI, or I can upload a lexicon from a CSV file. This can make it easier to work with when you want to copy-paste a large number of key phrases, for example. Let's build a lexicon and upload it. First, I'll find a list of airlines by just searching the web. I'll copy and paste this list into Excel and filter out the rows I don't want. For column B, I need to put the slot name. I'll make it be Airline. And I'll save it as a CSV. And now I'll upload it to Cognigy. So in just a few minutes, I have a new lexicon with 175 different airline names. I could have added synonyms to column C in my spreadsheet, or I can enter a few here in the user interface. If you want to add multiple tags or synonyms to your spreadsheet, or if you want to include data with your key phrases, you can do so. Search for CSV in Cognigy's documentation to find the detailed format for lexicon uploads. With this long list, I can page through the results and control the number of rows per page. To delete an entry, you have two options. You can delete a single entry by clicking the down arrow on the far right side of the row and clicking Delete. You can also click the checkbox to the far left of the row and then click Delete at the bottom of the screen. Cognigy also has some built-in slot types. They are similar to the built-in lexicons, but are more rule-driven rather than having a specific vocabulary. Cognigy automatically recognizes dates, numbers, durations, temperatures, ages, emails, and percentages. You might recall we saw some of these as built-in tokens in our say nodes and if nodes. I'll talk about how to use your lexicon in a few minutes when we build intents and test them out. Before we do that, I want to raise a point about organizing your lexicons. In the example I've shown, I had a separate lexicon for airport codes and airlines, but I could have combined those into a single lexicon. Because I can categorize key phrases using slots, I can have any number of slot types in a single lexicon. Lexicons aren't inherently tied to a single topic. They're just a convenient way of organizing our lists of key phrases. You can even use the same slot in different lexicons if you want to. So what should your approach be? A single lexicon with all of your key phrases, or multiple lexicons organized topically? In general, you should organize your lexicons topically. The reason to do this is that you may want to export and import your lexicon into another project, and having multiple topic-oriented lexicons lets you export just the category you want. If you are editing all of your lexicons in Excel, it also lets you have different subject matter experts managing their own list of terms without having to merge them back into a single lexicon. That said, you might have one lexicon that has all of the various minor topic areas that just have a few key phrases. In terms of slot names, it's helpful to have a standard you're working with as a naming convention. I recommend slot names that start with a category word, if it makes sense, have no spaces, and describe one row of the lexicon. For example, I would generally prefer airport code and airport name to airport codes and names of airports. How you organize and name lexicons, slots, and key phrases is up to you, and it's helpful to give it some thought in advance so that everyone on your team has the same rules in mind. Key phrases are one ingredient of Cognigy's NLU. Let's turn our attention to the other ingredient, intents. An intent captures the main idea of a user's objective when they type or speak something to your bot. So if the user says, "Is my flight on time?" or "Is my flight running late?" they need the flight status intent. Or if they say, "I want to go to San Francisco on the 28th," or "I need to go from SFO to DUS," they need the book a flight intent. In Cognigy, we create intents using the intent editor. To find the intent editor, go to your flow and click NLU at the top of the screen. Let's start by creating a flight status intent. I'll click Create Intent and name it Flight Status. Now I need to give Cognigy some examples of how users might ask about their flight status. Things like, "Is my flight on time?" "How late is my flight?" "Is my flight delayed?" I'll save and click Build Model. We need to build the model in order for Cognigy to take a freeform user input and match it to an intent. We can test this out in the Interaction panel. I'll open the Interaction panel by clicking the bubble in the top right corner. Now I'll do something new. I'll click on Settings here, and then I'll turn on Expert Mode. Expert Mode gives you feedback on things like intent matches and slot matches, so you can see how the bot is interpreting a user's input. All of the Expert Mode messages only appear here in the Interaction panel and won't show when an actual user is on the web chat on your website or on any other channel. Now I'll go back to chat here to talk to my bot, and I'll ask, "I need to check if my flight is on time." Cognigy gives us the feedback that the flight status intent was matched, and it gives us the intent score. The intent score describes Cognigy's level of confidence in the intent match. Let me try something else, like "How late is my flight?" That got a 1 as an intent score because it actually matches an example sentence. I want to enable Cognigy to use the lexicons I created, so I'll go to Attached Lexicons and enable the airports and airlines lexicons. I need to build the model again for these changes to be applied. What if I say, is my United flight to SFO on time? You'll see that I get 2 key phrase matches for both the airline and the airport. Let's create a second intent called lost baggage. And add some example sentences like, is my baggage delayed, or where are my bags? I'll save and build the model. And I'll test. We still get the right intent match, even though there is some overlap in the example sentences. Flight status has the phrase, my flight was late, and lost baggage has the phrase, where are my bags? But Cognigy is smart enough to know the better match. I'll create one last intent called baggage carousel. And I'll save and train. To test, I'll say, I went to the carousel, but my bags aren't there. One thing you will see is that there are many common English words that are also airport codes. We can ignore that for now, as it won't affect the intent detection. More importantly, however, we got the baggage carousel intent, but this really sounds like it should match lost baggage. The passenger knew the right carousel but still couldn't find their bags. So we need to look at our intents and figure out what went wrong. Cognigy provides indicators that can guide you to fix misunderstood intents. You'll see red, green, and yellow lights that characterize the quality of the example sentence or the intent. Note that red or yellow lights aren't necessarily bad, but they do give you good starting points when you aren't getting the accuracy you expect. If I look at baggage carousel and lost baggage, I see that they both have red lights next to them. Baggage carousel and lost baggage both indicate that there are strong overlaps with each other. There are different ways we can solve this. First, if I look at my lost baggage intent, I don't see the word carousel in my example sentences, so I could add a sentence here that includes that word. I can also look at my red light example sentences, and I see that where are my bags and can't find my bags are example sentences that are present in both intents. This could be bad and indicate that we need to distinguish the example sentences. Or it could be okay, because can't find my bags could potentially mean 2 different things in different contexts. And we can control this with states in Cognigy, a topic we won't touch on in this session. I'm going to do 2 things. I'll eliminate can't find my bags and replace it with where are my bags coming out from my baggage carousel example sentences, and I'll mention the carousel in my lost baggage intent. For the lost baggage intent, I'll add mention of the carousel. Now I'll build the model and test. Now I get the lost baggage intent, which is what I expect. The point of this exercise is to give some guidance about your example sentences. When you're creating your sentences, think about what makes a sentence unique for this intent versus other intents. What content distinguishes this example sentences as fitting for this intent? Note that example sentences don't have to be sentences. They can be phrases or sentence fragments, as long as they are useful data that can help Cognigy build an accurate model. I want to show one other way you can improve your intent detection. If I enter this example sentence, I get the right intent match, but the intent score is fairly low, less than 50%. How can I address this? I could add this example sentence, but there are many variations of this. I can't have one example sentence for every combination of airport codes. I can address this with annotation. I'll add this example sentences, check the status of my flight from SFO to ORD, and then I'll highlight SFO and click the plus sign next to it. This lets me tell Cognigy that SFO is a match for my lexicon slot airport code. I'll do the same thing with ORD. I can do this with airlines as well. Now I'll build the model and test another example sentence. I get a very high intent match, even though LAX and DUS aren't anywhere in my example sentences. I've been editing all of these intents in the intent editor, but I can also upload them and download them as I did with lexicons. I'll upload a larger set of intents now so we can see what it's like to work with a larger data set. I'll turn off my airport and airline lexicons as I won't need them for this new set of intents. One thing you'll note is that the intents have been categorized by naming convention. So the alarm-related intents all have alarm at the beginning, and the audio volume intents start with audio volume. This is a good approach as the number of intents you manage increases. In Cognigy, you can also use hierarchical intents to manage large numbers of intents. As an example, I'll create an alarm intent. Now I'll drag all my alarm intents under that intent. I just drag the intent name onto the alarm intent and it creates a hierarchy. I'll do that for audio as well. As you can see, this creates a nice visual categorization that can make it easier to find intents. I can create new child intents by going to any intent and choosing Create Child Intent. Organization is one reason to have intent hierarchies. Improved intent detection is another. Let's look at an example. I'll say, cancel this Friday's ballet class. I get an 87% intent match, but it's actually for the wrong intent. It identifies calendar set for the intent rather than calendar remove. Let's organize it hierarchically and see what results we get. This time for the calendar intent, I'll turn on Inherit Example Sentences from Child Intents and save. Then I'll build the model. Now when I repeat my statement, cancel this Friday's ballet class, I get the expected intent match, calendar remove. How did creating hierarchical intents take me from a misunderstood intent to a correct intent match? With hierarchical intents, Cognigy takes a somewhat different approach to intent matching. When I enable Inherit Example Sentences from Child Intents, Cognigy treats all of the example sentences from the subintents as part of the parent intent. Cognigy first tries to find an intent match from all of the highest level intents. Once it gets a match at the parent level, it then goes to the child level to do a more granular analysis. Think of it as a two-step process. Cognigy's NLU first tries to find a category level match. Once it finds the right category, it does an intent match just on the intents that are part of that category. Sometimes Cognigy finds an intent match that is close, but doesn't quite meet the confidence threshold. In those cases, we have the ability to ask users to confirm that we have the right intent match. Let's look at our cooking recipe intent as an example. If I go down to the Advanced section, I'll see the option to add a confirmation sentence. When a user sends an utterance to Cognigy, the NLU will attempt to find an intent match and attach a score to it, as we've seen. If the score doesn't quite reach the confidence threshold, but it does meet a reconfirmation threshold, Cognigy will output the confirmation sentence, typically a question. If the user responds to the confirmation sentence affirmatively, Cognigy will remember the confirmation throughout the rest of the conversation. If a certain number of users confirm the sentence will be added to the list of example sentences trained to this intent. Let's see a concrete example of this. I'll add the confirmation sentence to my cooking recipe intent. You have a recipe question. And I'll build the model. To demonstrate this feature, I need to make some changes to the default thresholds Cognigy has for confidence and reconfirmation. To do this, go to the Manage and then Settings in the left bar. Under Thresholds, I see a couple of sliders, and I'll make some adjustments to them. I'll move the confidence threshold to 90% and the reconfirmation threshold to 80%. And then I'll save my changes. I'll ask, how do I make 5-alarm chili? It now asks a reconfirmation question. This is because I have an intent match greater than 80%, but less than 90%. I'll answer yes, and now I have a match for the cooking recipe intent. This feature helps you address those borderline cases where you have a close but imperfect intent match. An important note here: if you haven't defined a reconfirmation sentence for your machine learning intent, the reconfirmation threshold is used to determine an intent match. So the reconfirmation threshold is used in two different ways depending on the existence of a confirmation sentence. With a confirmation sentence, the reconfirmation threshold triggers the reconfirmation sentence. Without a confirmation sentence, the reconfirmation threshold serves as a confidence threshold. We've talked a lot now about intent detection, but how do we respond to users once we know their intent? You have two options: handling responses in flows and handling them in default replies. You handle intents in flows when you have some logic you want to execute. So, for example, you may want to ask a follow-up question or retrieve data from an external system. But if you just have a simple response to a simple question, you can just put it in a default reply. As an example, let's look at the general praise intent. This intent lets the bot receive a compliment. Let's respond by saying thank you. I'll go down to default reply, and I'll see something that looks very similar to a say node. I'll just say thank you and save. Now if I tell the bot, "You are great," it says thank you, which comes from my default reply. One last note about the intent editor. You'll see the Build Model button has a drop-down arrow next to it that lets you do a quick build. This option will build a machine learning model for your intents, which doesn't contain specifications for states and intent conditions, and is thus up to 10 times faster in building your model. We could have used this option throughout this session, as we aren't using states or intent conditions. There are a number of topics we don't cover in the Foundations course that relate to intents. Those include rule-based intents, intent entry points, attached flows, maintaining intents in different flows, triggering intents automatically, and using external NLUs. We'll cover those in other courses, and you can learn more about these in the documentation. Before we leave the topic of intents, I want to talk about how to monitor and improve intent performance. The reconfirmation threshold feature helps Cognigy learn on its own. But how can you take part in the NLU's continued education? There are two tools for doing this in Cognigy: the Intent Trainer and Cognigy's Analytics. You can find the Intent Trainer in the left bar under the Tweak category. The Intent Trainer presents the collected user inputs and gives you the option to update your example sentences based on how users are actually interacting with your bot. For example, I can see that 2 people have asked, "How do I make 5-alarm chili?" It triggered the correct intent, but I can consider adding it to the cooking recipe intent to make sure there's still a match, even if other example sentences change over time. I can click Add to Intent, and I can choose the flow and the intent I want to associate this example sentence with. I can also make adjustments to the example sentence. Sometimes the Intent Trainer can serve as inspiration, but I don't want to add the user's input verbatim to my example sentences. I can change the text and even add annotations, create new key phrases, or create new synonyms. When I save my change, Cognigy queues it up and lets me keep working through the list. I can continue one by one, adding, skipping, or ignoring user inputs. If I skip an utterance, it gets moved to the skipped records list, but it will show up here again if a user enters the same input. If I click Ignore, it will move the input to the ignored records list, and it won't show up on this list anymore. When I click Apply, Cognigy will save my changes, and I can continue to work through my list. I can use the helpful filters at the top of the list to target specific flows or intents, or to move from my unhandled list to my handled, ignored, or skipped lists. One final feature worth mentioning: you can click on the vertical ellipsis to import or export trainer records. This can be helpful if you have a non-production environment that you use for reviewing training data and training your model. It lets you do the more data-intensive work of training your model in an environment that isn't accessed by your end users. The other approach to analyzing your intent performance is to view the raw records in Excel. To do this, search for OData in Cognigy's documentation. This will let you view every user input and filter by records, for example, that don't have intent matches. And that's all for now regarding intents in Cognigy. We've covered a lot of topics, and I hope you'll look for more in Cognigy's documentation and help center.